Alright, page 3. If y sub p contains terms that duplicate terms in y sub c, then y sub p must be multiplied by x sub n, where n is the smallest positive integer that eliminates that duplication. All that's saying is what we did in the last problem. Last problem, our y sub c, we had a solution of c sub 1 e to the 4x. And then our particular solution, we said we originally needed a e to the 4x. Well, there's two cases in this. Case one is where you don't have to introduce a new x, but since here we already have a solution, c sub 1 is a constant, a is a constant. So we need to make this different, and just like we did in the last section, we introduced that x. Well, that's what we're going to have to do here. We're going to have to introduce an x. And so since this is c sub 1 e to the 4x, a e to the 4x, I'm just going to introduce an x there, and then I'm good there. Now say, hey, our y sub c kind of duplicated twice, and say we had a c sub 1 e to the 4x, and when we were solving the complementary, we got another 4. And so we did plus c sub 2 x e to the 4x for the complementary. Then that means if our initial particular solution would have been a e to the 4x, well, since I already have it, since I already have this there and I already have the next, then it's going to be a x squared e to the 4x. And that's what this is saying, all right? That if you have how many ever times there's a solution there, then we just need the next one multiplied by x to whatever. So if this would have been the third one, it would have been ax squared e to the 4x. All right, so let's look at an example. Now, this is a good example because this is also, again, constant coefficients of a differential equation where it's set equal to a non-homogeneous. But in this case, we kind of have two parts. We have this part, which is just 16, which is a constant. And so I'm going to call this y sub p of 1. Well, when we just have a constant, if we go back to page 1, we're told that then our undetermined coefficient, or solution, should have a here. But then we have minus a, then we have minus x plus 2, which is a linear equation or a first degree polynomial, times e to the 4x. And if I go back to my paper here, then that should be my y sub p of 2. And that's going to be, this is a first degree, so it's going to be bx plus c, and then we're going to have e to the 4x. So that's what the particular solution should be. So it should be a combination of the two. And so my y sub p is just, and this is kind of like the superposition principle. We're just going to add these two, and there's still going to be a solution. So it's going to be a plus bx plus c. I'm going to leave a little space there because I have a feeling something's going to pop up, e to the 4x. And so now, let's go ahead and solve for the non-homogeneous part, which is going to be y double prime plus 2y prime minus 24y. So I'm going to have m squared plus 2m minus 24 equals 0. When I solve for this, I'm going to get m minus 4 times m plus 6 equals 0. So my m's are going to be a positive 4 and a negative 6. So y sub c is going to equal c sub 1 e to the 4x plus c sub 2 e to the negative 6x. And so then I'll look to see if anything will duplicate. And yes, I already have an e to the 4x over here. When I distribute this, it's going to be c e to the 4x, and it's going to look very similar to this one over here. And so what I'm going to do is, because I already have the solution, I'm going to multiply the inside of here by x. That way I don't have a repeated solution. So bx squared plus c x, and I'm going to do that here also with the y sub p. So because I already was going to have a solution there, I had to multiply by x, and now what I can do is I can now go ahead and take the derivatives of this and then solve for that. So y prime of p is just going to be the derivative of a0. That's great. Product rule. We'll get through this. So we have the derivative of bx squared plus cx. The derivative of the inside of that is just going to be 2bx plus c times e to the 4x. And then take the derivative of e to the 4x, which is just going to be 4 times bx squared plus cx e to the 4x. All right? And then we need to do it another time because this is taken to the second derivative. And so here, I'm going to make some more room. Y double prime of p is equal to, so the derivative of the inside, which is just going to be 2b times e to the 4x plus the derivative of 4 times 2bx plus c e to the 4x plus the derivative of the inside over here, which is going to be 4 2bx plus c e to the 4x. Looks similar to both of those two, so that's good. Plus, and then 4 times 4 is going to be 16bx squared plus cx e to the 4x. Right. Any questions? So, again, you can't ask questions. So I'm sorry. If you have questions, just email me and I can do some more of these examples. And so now we got to put everything into our differential equation. We're going to have all this, which is going to be 2b e to the 4x plus, now these two are similar, so I'm just going to combine them. 4 plus 4 is 8, so 8 2bx plus c e to the 4x plus 16bx squared plus cx e to the 4x. And now plus 2y prime, so plus 2. I'm going to go ahead and distribute that 2. So I'm going to have 2bx plus c e to the 4x plus 8bx squared plus cx e to the 4x, and then minus 24, a minus 24 bx squared plus cx e to the 4x, and that all equals 16 minus x. I'm going to go ahead and distribute. No, I won't distribute yet because I already put the parenthesis there. E to the 4x. And now we got to see if anything cancels out. And if I add this to this and subtract this, those are all going to cancel out. And then I'll distribute where I can distribute. And I want to see what I get. And so since I've already done the work here, I'm going to have negative 24a. Have a 2be to the 4x. And I have a 16bx e to the 4x. And I have a 4bx e to the 4x. So I'm going to combine those and just get plus 20 bx e to the 4x. I'm going to cancel that part out that I just did. And the only thing that's left are these, this 2be to the 4x and then the ce to the 4x. So I'm going to have a plus 2b, and let's see, 8 plus 2 is 10, so plus 10 c e to the 4x. So all of these are e to the 4x's. I'm going to put my parentheses there so that you just can see the coefficients. All right, and now this is set equal to 16. I'm going to distribute and get negative x e to the 4x plus 2 e to the 4x. And now I'm going to set things equal where I can. So now this negative 24a, that's just the constant. And so I don't know why I should have included the whole thing. So negative 24a is just the constant. There's no functions of x beside it. So that's going to be set equal to 16 over here. The 20b right here, x e to the 4x, is going to be the coefficient right there. So that's going to be equal to negative 1. So I have 20b is equal to negative 1. And then my last one, which is this e to the 4x, that's going to be set equal to 2. So it's going to be 2b plus 10c is equal to just positive 2. And so now we're going to do some math, and we're going to find out that our a is just equal to negative 2/3. Our b is going to be negative 1/20. And then here we got to plug in for b what we know what it is. So it's going to be 2 times negative 1/20 plus 10c equals 2. And so we can say that c is equal to negative 19 over, not 200, but 100. And so then our y sub c, y sub p is going to be equal to, remember up here it's a, which our a is negative 2/3, so negative 2/3, plus b, which is going to be negative 1/20 x squared, plus c, which is minus 19 over 100 x e to the 4x. And so we can find our general solution now. In our general solution, when we combine our y sub c with our y sub p, is y equals c sub 1 e to the 4x plus c sub 2 e to negative 6x plus minus 2/3. You know what, I'll go ahead and say minus 1/20 x squared plus 19 over 100 x e to the 4x. And there's the solution.